Okay, today we are looking at lesson 2.3b, so everybody should have their module open to page 39 and your pencils ready. And for the problems on page 39, we are adding and subtracting fractions. And a reminder from what we learned in elementary school is that in order to add and subtract fractions, we must have a common denominator. So I'm going to make a note of that up at the top, and I want you to do the same. So if we look at number 1, we'll notice that the denominators are already the same, so we don't have to find a common denominator. In my answer, I will have a denominator of 17, and in order to find my numerator, I have to do the problem -6 plus +1. So thinking about the chip model that we looked at earlier in Module 2, we know there would be 6 shaded chips and 1 unshaded chip, so we'd have 1 zero pair and 5 negatives remaining. -5/17 is a proper fraction and its simplest form. So that is our answer, and we'll box it and move on. For number 2, I noticed that the denominators are the same, but this time I'm subtracting a negative fraction. So just like we learned earlier in Module 2, we're going to rewrite this problem as addition of the opposite. So my 25/9 will stay the same, but I will change subtraction to addition, and my -7/9 will become +7/9. In my answer, my denominator will be 9, and to find my numerator, I have to add +25 and +7, which of course is 32. 32 over 9 is an improper fraction, and we can change it to a mixed number. 9 divides into 32 3 times, which is 27, and the difference would be 5, so 3 and 5/9 would be our mixed number for number 2. Moving on to number 3, we have a common denominator, but we also have a mixed number. So I'm going to change that mixed number 1 and 6/11 to an improper fraction. So I have my 7 over 11, and I'm subtracting from it. To make it improper, I want to multiply 11 by 1, which is 11, and add the numerator 6, which gives me 17 over 11. Now, just like number 2, this one is subtraction. So to make it a little clearer what's happening, I'm going to change it to addition of the opposite. So I've changed it to plus -17/11. My denominator in the answer will be 11, and to find the numerator, I need to think about 7 plus -17. This is going to result in 7 zero pairs, leaving me with 10 negatives. So -10/11, which is proper and simplified, so that is our answer, and moving on to the next row. For number 4, this is the first one where we have an unlike denominators. So 3 and 4, we have to think about a number that they will both divide into evenly. And the least common denominator would be 12. So I'm going to change both of these so that they have a denominator of 12. And that means I have to look back up at my original denominators. I multiplied 3 by 4 to get 12. So 2 times 4 will give me 8. And of course that -2/3 was negative, so -8/12 is negative as well. I've multiplied 4 by 3 to get a denominator of 12, so 1 times 3 gives me a numerator of 3. And now I have -8/12 plus 3/12. Of course my denominator will be 12, and my numerator will come from the problem -8 plus 3. I would have 3 zero pairs and 5 negatives remaining. So -5 over 12, which is simplest form and proper. Moving on to number 5, I have unlike denominators again, so I'm going to have to change the 3 and the 6 to a denominator that both will divide into evenly. I can use a denominator of 6, so my first denominator 3 I've multiplied by 2, and if I multiply my numerator by 2, I have 2 over 6. Note that that simplifies to 1/3. If I look at my second fraction, I've multiplied 6 by 1 to get 6, and so 5 times 1 is 5. In other words, that fraction doesn't change. I can bring down the subtraction sign, but like I said earlier, it makes it a little clearer if I rewrite subtraction as addition of the opposite. So instead of minus 5 over 6, I'm going to change it to plus negative 5 over 6. Of course, my denominator will be 6, and for my numerator, I have to do the problem 2 plus negative 5. 2 zero pairs and 3 negatives left over, so negative 3 over 6. This is a proper fraction, but not simplest form. So if I divide both my numerator and my denominator by the common factor 3, I can simplify to 1/2. Of course, we can't forget the negative sign. For number 6, I have a problem in that I don't have a common denominator for the two fractions, so we'll have to think about that. Also, I'm subtracting a negative, so it would be much clearer if I change it to addition. So I'm first going to rewrite it as 2/3 plus positive 3/2, cleaning it up a bit. And now I'll think about my common denominator. Both 2 and 3 will divide evenly into 6. 3 I've multiplied by 2 to get 6, so the numerator 2 times 2 will give me 4. 2 I've multiplied by 3 to get 6, so my numerator 3 times 3 will give me 9. If I bring down my addition sign and complete the problem, I have a denominator of 6, and 4 plus 9 is 13. 13 over 6 is improper, and I can make that a mixed number. 6 will divide into 13 two times, which is 12. So I have 1 remaining, and I can write that as 2 and 1/6. On to the next row. For number 7, I have two mixed numbers, and I have my choice. I can either leave them as mixed numbers and find a common denominator and go about the problem that way, or I can make them both improper, find a common denominator, and go that route. I think at this point it might be easier if we make them improper fractions, and then once we get the hang of this, maybe on Friday or sometime next week, we can look at leaving them as mixed numbers. But for now, I will make them improper. So 4 times 2 is 8, plus 3 would give me 11. I have 11 over 4. I'm subtracting from it 1 and 2/3. 3 times 1 is 3. If I add 2, that gives me 5, so 5/3. Of course, now I need a common denominator. For 4 and 3, we can use 12. And now I have to change my numerators as well. So 4 times 3 I multiplied to get 12, and 11 times 3 will give me 33. 3 times 4 gives me 12, and 5 times 4 will give me 20. And again, instead of bringing down the subtraction sign, I'm going to change it to plus a negative. So anytime I'm seeing subtraction, I'm rewriting it as addition of the opposite. My denominator will be 12. And if I think about the chip model, I've got 33 positives, 20 negatives. So 20 zero pairs and 13 positives remaining. That is, of course, an improper fraction, and 12 goes into 13 one time with 1/12 remaining. So 13 over 12, or 1 and 1/12. For number 8, I'm going to tackle this problem the same way. So I'm going to change both mixed numbers to improper fractions and then find a common denominator. 7 times 3 is 21, plus 5 is 26. So 26 over 7, and of course I need to bring down that negative sign. For negative 1 and 1/2, 2 times 1 is 2, plus 1 is 3. So 3 halves, and that's negative, and I'm subtracting it. Notice when I changed those mixed numbers to improper fractions, I ignored the negative sign, but then I remembered to include it with my improper fraction. If I rewrite this now as addition, it will make it a little bit clearer. So I have negative 26/7, which I'm not changing, and I'm going to add a positive 3 halves. Now for a common denominator. Both 7 and 2 will divide evenly into 14. And 7 I've multiplied by 2 to get 14, and 26 times 2 will give me 52. So 52/14, and don't forget the negative sign. 2 we've multiplied by 7 to get 14, and of course 3 times 7 will give me 21. And I am going to be adding those. I'm out of room, so I'm going to continue up here, which may not be the best plan, but it's the only option I have. My denominator will be 14. And I've got 52 negatives, 21 positives, so I'll have 21 zero pairs, and I'll be left with 31 negatives. So negative 31/14, or 14 will divide into 31 twice, which is 28. That leaves us with 3, so 2 and 3/14, and again, don't forget that negative sign. Okay, next up is number 9, and I have an improper fraction and a mixed number, so I'm going to make them both improper. Negative 4/3 is good to go, and I need to change negative 1 and 5/12. So 12 times 1 is 12, plus 5 would give me 17/12, and of course negative sign needs to come down. My common denominator will be 12. So my first numerator needs to change, but the second numerator will be fine as is. Back to the first fraction, I've multiplied 3 by 4 to get 12, and so 4 times 4 is 16, negative sign included. 12 times 1 is 12, and 17 times 1 is 17, so again that one doesn't change, but I do need that negative sign, and my operation, I'm adding those together. My denominator will be 12, and I'm going to add the numerators because I'm going to have 16 negatives and 17 negatives. In other words, no zero pairs, and that's going to give me negative 33/12. This improper fraction can be simplified. These two numbers have a common factor of 3. So if I divide by 3, that's going to give me negative 11/4. And of course it's improper, so now I can make it a mixed number. 4 will go into 11 2 times, which is 8. And so I have 3/4 remaining, and I want to bring my negative sign over. So negative 11/4, or negative 2 3/4.